First of all, thank you everyone for joining us today. Some of you may know me, some of you may not, but my name is Zach Mowen. I'm a senior account executive here at Suitebriar. And as many of you may know, Suitebriar is a Google Cloud Premier partner and a value-added reseller. We specialize in all things Google Cloud from both the Google Workspace side and Google Cloud Platform. And obviously you're here today because this is going to be focusing on GCP and understanding security. With that, I would like to introduce two members of the Suitebriar team that have joined us today, Ahmed and Sanjan, who lead our GCP team. So during the presentation, please, if you have any questions, if you could hold those to the end, or please feel free to enter them into the chat along with your email address. If I'm not able to answer them on the call today, then we'll be sure to follow up and address them directly with you. And also, we'll be recording today's session and sharing that with each of you via email. So without further ado, I'll go ahead and pass the torch over to Ahmed so we can get started.
Cool, thank you. All right, hello everyone. Welcome, first of all. Today we're going to be talking about governance on GCP and what the implications are of improperly configured cloud environments. Let's go on to the next slide. All right, so before we get into all that though, let me tell you a little bit about myself. As you guys already heard, my name is Ahmed Kamel. I've worked in the cloud engineering space for roughly a decade now. My experience varies from working on small-scale startups to large corporations serving millions of users every day. One of the things that I enjoy doing is building out these massive, large-scale environments that can handle scaling out with very little human intervention. One of the things that drives me in this industry, though, is automation. With proper automation in place, engineers are free to focus on enhancing and driving new features out the door. All right, so today we're going to be talking about a couple of different topics. The first topic is the shared responsibility model. Then we're going to get into IAM roles, organization policies, security command center, network security, and finally logging, with a little bit of time for some Q&A at the end. So mainly, we're going to be taking a deeper dive into the different offerings that GCP gives us so that we can keep our cloud environments nice and safe. In the modern era, keeping your cloud environment secure should be the top priority of any organization. One of the first topics on the list is the shared responsibility model with GCP. So what is the shared responsibility model? Well, that model is, depending on what service you're using in GCP, the responsibility model will change. The more you offload to GCP, the less you need to do yourself. One way to think of it, though, is like eating a pizza. So if you're a busy college student, you can get a pizza delivered straight to your doorstep. This would be the software as a service portion of the model. You're just responsible for getting out some plates and eating the pizza. In GCP land, think of something like the Apache Kafka service or the Elasticsearch service. They take care of most of the heavy lifting to get you these small function, or to give you a fully functional service. But let's say you're not quite as busy as a college student. You have a little extra free time in your hand and you want to do something fancy. You can go grab a pre-made dough and all the ingredients and put your pizza together and cook it your own way. Now, this is the platform as a service portion of the model. You share splitting the workload with whoever made the pre-made dough that you end up buying from the store. So here, you're sharing more of the responsibility with GCP than before. From GCP land, though, think of platform as a service offering to be something like Google Cloud Storage, where they'll maintain all the infrastructure and you can just put whatever objects you want into that storage. So back to our analogy, though. Let's say you're a pizza connoisseur. You want to make the dough from scratch, and you want to wait for it to rise and all that fun stuff. Well, you still need to go to the grocery store, buy the ingredients, buy the dough, and buy everything that you need to make that dough. Then you cut up all the ingredients and all the toppings and put the pizza together and bake it. So this is infrastructure as a service. GCP in this scenario is providing you with all of the basic building blocks, and you have to do something useful with it. So for this, think of something like compute engine. Compute engine is one of the most fundamental offerings that GCP has. It is the basic building block that a lot of other GCP services are built on. It's essentially a blanket slate virtual machine that you can do whatever you want with. So let's break this down, though, for the shared responsibility model. For compute engine, GCP is responsible for the underlying infrastructure, the hardware, the firmware, the kernel, and the networking for the virtual machine. They even install the operating system on the virtual machine for you. On the other side, though, you're responsible for managing the workload that runs on that virtual machine. You'll need to install whatever software you need onto that compute instance. So what are the implications of the shared responsibility model? Well, getting a clearer understanding of that model will help your organization in several ways. But first and foremost, it can help you overcome security challenges because you'll have a better understanding of what you're responsible for versus what GCP is responsible for. It can even help with troubleshooting production level outages. You'll have a clearer understanding if there's a failure on GCP's side of the service or on yours. All right, let's talk about IAM now. For those who don't know, IAM stands for Identity and Access Management. So what is IAM and what are IAM roles? Well, IAM will allow individuals and services to interact with your infrastructure and other GCP services. You can also restrict individual users' access to specific services and projects. With IAM in general, it's considered best practices to take the least privileged approach. Not every developer needs access to every project. So for example, if you have a project that controls your production database, the summer intern that just started last week doesn't need access to that project. In GCP, there are 3 different types of IAM roles. There's the basic role, the predefined role, and the custom roles. So let's talk about these a little bit. Basic roles are exactly what they sound like. They are the roles that come out of the box and have very broad permission. GCP provides 3 basic roles for you. There's the owner role, the editor role, and the viewer role. In general, though, it's not considered best practices to use these roles in any production environment, but you can assign them to individuals. All right, next is the predefined roles. These roles try to cover some of the shortcomings of the basic roles. Like the basic roles, though, they are also created and managed by GCP for you. Google will update these roles as new GCP services become available and new features are added to them. Predefined roles give you more fine-grained access control than basic roles. So individual users can have multiple predefined roles assigned to them. So for example, a user can have the compute network admin role and the log viewer role assigned to them at the project level, and also have the PubSub publisher role to give them access to a specific PubSub in a different project. And last on the list is the custom roles. These roles give you very granular level permissioning. They'll help to enforce the principles of least privilege that we kind of discussed about earlier. They allow you to give users in your organizations very fine-grained permissioning. All right, so what happens when IAM goes wrong? What happens when IAM users are not deleted properly or an IAM role is given too broad of permissions? These types of scenarios can happen all the time, and they lead to major security problems. Let's take 2 scenarios here. One dealing with a malicious actor and one dealing with a developer just trying to get a new feature out. All right, so for the first scenario, we have an engineer whose IAM credentials got compromised, and a malicious actor got a hold of them. If this engineer's credentials give the malicious actor broad access into your entire infrastructure, they can cause some irreversible damage by the time the threat is detected. They can even spin up a crypto mining rig in your infrastructure, and you get stuck with the bill. All right, so the other side of this, though, is an engineer just simply trying to develop a new feature. Say this new feature requires the engineer to create a cloud storage bucket. If you have an over-restricted IAM strategy and no good automation in place, this simple request can take several hours to complete and slowing down productivity completely. That's why it's important to try to find a balance in your IAM permissioning strategy between restrictive and too broad. All right, next on the list is organization policies. What are they and what can they do for you? Organization policies will allow you to have centralized control over the entire organization's cloud presence. From one central place, you can control how all of your different GCP services are used and managed. So let's talk about a couple of different services, and let's see how organization policies can help you manage them. First one on the list is IAM again. With organization policies, you can set some hard limits on what individuals can do with IAM. You can set restrictions on how audit logging exemptions can be controlled, on how cross-project service accounts can be used, or even if service accounts can be created in general. These are just a few of the possible knobs that you can control with organization policies for IAM. Next, let's look at Cloud SQL. This is an important one. Some of the most vital pieces of infrastructure within any organization are their databases. If a database gets compromised, you and your team are not going to have a good day. Unfortunately, though, organization policies only give you 2 knobs to turn for Cloud SQL, but they're very important. The first one of those is which networks are authorized to communicate with your database. So, for example, you can restrict access to the production database server to only production networks and block all other networks in your infrastructure from communicating with your database. So like your dev and staging environments. Those shouldn't be able to reach the production database, and this will help you to enforce that. The other knob that you can turn here is the public IP association with your database. You can set this to a hard no for any database that gets created within your GCP project. There are very, very few scenarios where you'll ever want your database to be publicly exposed to the internet or directly exposed to the internet. One thing to note is that these policies are not retroactive. So if you enable any of them, you'll need to go back and set them for the resources that have already been created. All right, last but not least, let's talk about Compute Engine again. Unlike Cloud SQL, there are many different aspects of Compute Engine that can be managed via organization policies. There's somewhere around 24 different options that you can control. So, for example, you can disable the creation of global load balancers if you want. You can disable IPv6 if your network doesn't support that yet. You can even enforce OS login for your virtual machines. Those are just a few examples of the services that you can control via organization policies. All right, so let's talk about the implications of not using organization policies or using them but configuring them incorrectly. So let's say, for example, it's Friday afternoon and someone on your infrastructure team is trying to wrap up a request that they got to create a series of cloud storage buckets. They misconfigured one of the settings on a bucket and it became publicly available without anyone knowing. Come next week, the engineer who made the request sees that the bucket is available and he starts using it right away. They start putting very sensitive customer information in that bucket. And bam, just like that, you have a data leak now. This is where organization policies come in handy. You can set policies that will block public access to a bucket that gets created automatically without having to rely on any individual. Another area where organization policies can really come in handy is when you're trying to get your PCI or SOC 2 certifications. You can set the required restrictions from one central place and you'll be comfortable knowing that it's enforced. All right, so now that we've talked about a couple of different GCP services and discussed some of their possible security concerns around them, let's talk about one service that lets you stay ahead of the game when it comes to security. This service is Security Command Center. GCP created this service to give you one centralized vulnerability and threat reporting service. Security Command Center has 3 key features that we should take full advantage of. First of those features is asset discovery and inventory. This lets you discover and view all your assets in near real time across a lot of different GCP services like Compute Engine, BigQuery, Cloud SQL, and even IAM. It can even let you do historical scans to find new or modified or even deleted assets in your project. This can come in very handy when trying to triage an outage or doing a postmortem. All right, next on the list is threat prevention. This is just what it sounds like. This feature will let GCP uncover common web app vulnerabilities running in your infrastructure and tell you about them. So for example, if your app is using some outdated libraries, and is deployed on a pod like on a pod in GKE, GCP will point that out to you. They'll even give you the recommended steps to take to resolve this issue. All right, the last key feature of Security Command Center is threat detection. This feature will use all the different logs that are generated within your GCP project and scan them for any possible threats. They can even go as far as to detect some of the more lower level container vulnerabilities like reverse shell. All right, so what are the security? All right, so Security Command Center is great, but what happens if you don't use it? Let's take our previous example from IAM Roles, where a malicious actor made their way into your infrastructure and started spinning up a crypto mining rig. Well, Security Command Center's threat detection feature will pick that up and alert you about it in near real time. So if you don't set up Security Command Center, you'll almost certainly have delayed responses to the malicious actors within your project. Let's take another example from the application side of things. December of last year, there was a massive security vulnerability announced for one of the most common Java logging libraries. The vulnerability became known as Log4Shell. Essentially, this vulnerability allows malicious actors to take control of any machine running the Log4Shell library. This is where Security Command Center's threat prevention really shines. Right after Log4Shell became public knowledge, organizations were able to use threat prevention to track down any systems in their infrastructure that was compromised. They were able to take immediate action to patch those systems as well. So, long story short, Security Command Center will go a long way in helping you monitor your GCP environment and make sure it's safely locked down and secure. All right, now let's talk about network security. The term network security is very broad and has many different layerings to it. Overall, though, the goal of network security is to make sure that resources within your network are only accessible by their intended consumers. There are many different aspects of network security that we can spend all day talking about. For today's presentation, though, let's focus on a few key items. Before we dive into that, though, let's go over some terminology. The term ingress in this context refers to any kind of network traffic that originates outside of a service and is routed to that service, while egress would be the exact opposite. So any requests that originate from the service and are headed to the outside world. Okay, now that that's out of the way, let's talk about firewall rules. In GCP, firewall rules are tools that you can use to control who can, and more importantly, cannot communicate with your resource. So, for example, your database can have a firewall rule on it that denies any ingress from the public internet while having a specific allow ingress rule from your API servers. Just a reminder, ingress in this context means traffic coming into your service or your database. When talking about firewall rules, it's always best to take the least privileged approach. By default, your service should only have required ingress rules on them and have deny on egress, meaning that outbound traffic should be denied by default unless that network path is required. So let's take a small example to get these concepts ironed out. Let's say you have a firewall rule on your production database. That database should have a deny ingress rule from all sources except the few API servers that will need to communicate with that database. It should also have deny egress rule on it for everything else. The reason for the blanket egress deny is because your database should never be initiating any connections to the outside world, only accepting them. There's only one important thing about firewall rules that you need to be aware of, though. Every GCP network has two default implied rules. The first of these rules is the allow egress rule. This rule gets applied to every resource created in your GCP network by default. What this rule does is a blanket egress allow to give any new resources that get created the ability to communicate with the public internet. The second implied rule is the deny ingress rule. This rule, like the first rule, is applied to all your resources in your network. It denies any communication with a new instance from the outside world. The reason for this is because one fundamental GCP principle is secure by default. The default network state for any resource that gets spun up in your network is secure. All right, that's firewall rules. Now let's talk about VPCs. VPC stands for Virtual Private Cloud. They essentially act as an umbrella that encompasses all networking resources. They can have a lot of different things in them, but let's take a look at two key concepts here: the private subnets and the public subnets. Private subnets is where your private assets like API servers and databases should live, whereas public subnet is where any public-facing assets like public load balancers should be created. The reason behind this is because the private subnets don't have any direct ingress routes from the public internet. So your API servers and your databases will have some level of protection on them from a network routing point of view. Using private and public subnets properly is very important to help secure your networks. All right, next, let's talk about cloud storage buckets. This is kind of a smaller topic, but it's worth mentioning at least. Cloud storage buckets, by default, should have audit logs enabled. That way you can see who's reading and writing from your buckets in the event that an audit is required. Also, like I mentioned earlier, cloud storage buckets should be created with no public access allowed unless there's a very good business need for it. Like with a lot of other services in GCP, cloud storage will let you use IAM service accounts to access and manage your buckets. All right, so we talked about a few different topics in networking, but let's talk about the implications of not having a secure first networking strategy. I said this a couple of times before, but the default mindset that you should have for any resources in your network is least privileged. If something does not need access to something else, then it shouldn't get it. If your service doesn't need access to the payments history database, then it shouldn't get access to that database. Let's talk a little bit more about that log4shell security vulnerability I mentioned earlier. Let's say that we have that vulnerability on one of our servers, and we aren't using Security Command Center or any other service, so we don't know about it. If we have proper firewall rules in place, we can limit the scope of any data breach. If the API server that a malicious actor has taken control of has limited egress rules on it, then the blast radius of that hack is severely limited. The person that took control of your server can't get to anything else on your network that API server doesn't have access to. This is just one small example of how taking a least privileged approach to your networking strategy can go a long way in protecting your organization. All right. Alongside taking a proactive approach to protecting your network, you also need a way to see historical data in the event that something bad has happened. This is where logging comes into play. GCP has many different forms of logging that they provide you. A lot of the services themselves have some form of logging to give us more insight into the behavior. So let's take a look at 3 different logging options that GCP offers us. First is VPC flow logs. These types of logs take a sample of network flows for ingress and egress traffic for a VM instance. These logs can be used for general network monitoring, real-time security analysis, and a lot more. VPC flow logs can tell you all of the different resources in your network that a specific server is talking to. Next is Firewall Rules logging. These logs let you audit and analyze the impact of your firewall rules. You can view these logs to see if your firewalls are behaving as expected. You can also use the logs to see how they are impacting your customers. You can see how much traffic an individual firewall rule is blocking or allowing, which is very helpful when trying to debug firewall rule related issues. Okay, last on the list is audit logs. These logs let you capture administrator activities as well as individual accesses within your project. There are a couple of different types of audit logs that you can see. One very useful one, though, is the audit log is the admin activity and system event logs. These logs have an entry for every API call into your GCP project. So, for example, let's say someone created a new virtual machine or changed the IAM roles attached to a virtual machine. You can see these events in the audit logs. The best part about the admin activity and system event logs, though, is that they're completely free. Because you as a consumer of GCP don't have the ability to turn these logs off, GCP won't charge you for them. So there's really no downside to using them. Of all of the different topics we've talked about today, logging is one of the easiest to forget about. If you don't have something in place to ingest your logs and audit them in real time, you're holding yourself back from truly rounding out your GCP project from a security point of view. These logs are not just for security, though. They can also help you figure out what's going on when you have a production outage. Let's take firewall rule logs, for example. Let's say that out of nowhere, a database stopped accepting traffic from any of your API servers. An engineer made a mistake and applied a firewall rule to the database that blocked all traffic to it. We go through the usual debugging procedures. We look and see the database is up and running and not overloaded at all. If we take a look at our firewall rule logs, though, for that database, we noticed that there was a new rule that got applied a little while ago. The logs then show that that specific rule has tens of thousands of hits on it and is blocking all traffic. And just like that, we found the culprit of the outage. We can then take the proper actions to remove that firewall rule and get our services back online. This is just one small example of how firewall rule logging can help you in real time. It's unfortunate to say this, but every organization is at risk of a data breach and network vulnerabilities. With proper logging enabled, you can at least have historical data to back up your investigation in the event that something like that happens. Proper logging will empower you to make sure something like that never happens again. All right, so we've talked about a lot of different topics today, but here's the gist of it. GCP will give you all of the tools you need to make sure your environment is secure and locked down. But it's up to you as a consumer to take full advantage of that and to help make sure your organization is protected from hackers and individuals that might threaten your data. Thank you everyone for attending this webinar. I hope you found some of the information presented today useful. And if you have any questions, like Zach mentioned earlier, please put them in the chat. And I believe Sanjan will kind of address some of those questions now.
Hi, thank you very much. I do see, my name is Sanjan. I'm the Technical Account Manager for Suitebriar. This demo that Ahmed has presented is very 1,000-feet overview in regards to the security and the security command center. When we have other plans for deep diving into technical demos in the future also, and also we are going to have one-on-one if somebody is interested. As you can see, Rita, Zach has already replied to you, and we'll be happy to have one-on-one demo with any of the clients and the teams that want to have one-on-one to show everything precisely what you can do from the configuration side. And in regards to that, I hope this is a 1,000-feet overview that is understood, and we will go over the deep diving demos in the future also. Thank you very much, and I'll pass it over to Zach.
Thanks so much, Sanjan. I appreciate it. Megan, if you would be so kind to put the link in the chat. So for anyone that would like to schedule a one-on-one session, go ahead and fill that form out. We can further discuss GCP with your team and talk about the other services that we offer. Whether you're interested in a cloud, cost comparison, guided cloud migration, or custom app development, we're here to assist. And as a thank you for scheduling time with us, we'll buy you lunch. We'll provide a $25 either Grubhub or Uber Eats gift card to each member of your team that joins. And so along with that, we're going to be sending out a follow-up, as I mentioned at the start of this, with an email containing the recording from today's event so you can review with other members of the team or just as a refresher, along with a brief survey. And we absolutely appreciate any feedback that you'd like to provide and how we can improve these. This is the first of a series of GCP webinars. So be on the lookout for our next webinar invite where we'll be discussing infrastructure as code. And with that, I think we're about 2 minutes over, so we appreciate everybody hanging in there with us. We hope today's webinar was informative. We can't wait to share the next one with you. And keep an eye out on your inbox for that follow-up email with the survey, and we'll put the link in there for the form to schedule a one-on-one with us as well. And again, thanks so much. Have a great day. All right, we're down to Suitebriar peeps.
Great job, Zach.